Okay, welcome to part 3 on our fraction book. And so far we've covered fractions of one and least common denominator, simplifying rules, and same denominator rules. We're going to use all of these things to go to our next part of our book, which is different denominator rules. And again, we're only going to talk about adding and subtracting. That's all we're going to talk about. We're going to keep it very simple. All right, so once again, like we always do, let's open up our book. And at the top of our book up here, we're going to put our steps, okay? So once again, here's our steps. So step number 1. Because the denominators are different, we're going to have to find the least common denominator. Okay, remember we called that the LCD, and remember we were talking about multiples, right? We're finding the least common multiple. Now you can find other common multiples, but the lowest one will have you do the least amount of work, and I think we want to do the least amount of work. Okay, step 2. We're going to multiply by a fraction of 1. Okay, that's step 2. Multiply by a fraction of 1. Step 3. Keep the new denominator. Keep the new denominator. Okay. Then step 4 is going to be add or subtract, depending on what we're doing, right? Add or subtract the numerator. And the last step always is to simplify if possible. Remember, it may not always be possible. So these are the steps that we're going to follow. Okay, we're going to do 2 addition examples and 2 subtraction examples. So all of the examples we're going to look at right now are going to have different denominators. So we're going to find that least common denominator, multiply by a fraction of 1, keep the new denominator, add or subtract the numerator, and then simplify if possible. And once again, that fraction of 1 is going to come back in to help us simplify. So it's going to help us make them bigger and make them smaller. Okay, so let's get down here and let's try to do some examples. So let's go here with example number 1. We're going to stay with adding first because that seems to work out the best. So let's take 1/2 plus 1/4. I know that most of you guys can visualize this and know what the answer is, but we're going to follow our steps. I always want to keep easy problems in here so we understand how this works. The denominators are different, 2 and 4. So we have to think about what is the least common denominator. We have to think about that, right? What's that least common multiple? If we think back to 2 and 4, remember, if you're counting by 2s and 4s, right? Both of them can go into 4. So 4 is going to be our least common denominator. This already has a one of 4. We want this one to have a denominator of 4. In order to do that, 2 times 2 will give us 4. So our fraction of 1 we're going to use is 2/2. So I'm going to make 1/2 be bigger. So it becomes 2 times 2 is 4, and 1 times 2 is 2. So now what I'm looking at is I'm looking at 2/4 plus 1/4. So now we're back to where we were before, right? With same denominators. Denominators are the same. And we just add the numerators. 2 plus 1 is 3. And we don't need to simplify this. This is as simple as it gets. Okay? I'm going to work my way going down this time. And we're going to say example 2 right here. All right? And example 2 is going to be 3/4 plus 2/3. Okay? So we have to think about that LCD again. LCD. What's it going to be? 3/4 plus 2/3. I think if you remember, I'm going to flip back to our, right here. We had done 3s and 4s, right? And we saw that our least common denominator was 12 when we did that. So let's use 12 because 3 and 4 both go into 12. So that's going to be our number. So now what you have to think about is you can set these up already to say equals to 12, so you're ready to go. And think about, this would be multiplying times 3, so my fraction of 1 would be 3/3. This one would be times 4, So my fraction of 1 would be 4 over 4. Now we want to do that because we really want to make sure we're not just multiplying the denominator, we're multiplying the numerator as well. So 3 times 3 is 9 here, and 2 times 4 is 8. So now we're going to go back to our normal way of adding and all this stuff that we've been doing. Keep the denominator, which is 12, and now I add the numerators, 9 plus 8, and now I get 17. You'll notice that this is an improper fraction. So I need to fix that improper fraction and change it. All right, so one of the ways we can do that is to do some long division. Some of you might remember that. Remember we talk about what's in the house, what's out of the house? So we read this 17 divided by 12. So what we're dividing by goes on the outside, dividing by 12. I want 12 pieces. So the 17, which is the numerator goes in the house. Okay, so I think 12 into 17 goes one time. I do my subtraction and I have a 5. So I have 5 left over. So this becomes 1 and 5/12. So 1 and 5/12. That's how we change an improper fraction into a mixed number. We do a little long division. Some people can do it visually. They can say, hey, I can get 1 whole and there's 5 left over, keeping that denominator. So that's another way to do it. All right, let's move on and let's do 2 subtraction problems. So let's do this one, example 3. Okay, and this time we're going to take the whole number 5 and I want to subtract 2/3 from it. Now, some people might be able to do this one in their head, and that's fine, but we're going to follow all of our rules. We don't have anything right here, and I want to take parts. So which means in order for me to do that, I have to borrow 1. So I'm going to borrow 1 from the 5, and it becomes 4, right? And I want a whole in thirds, so I'm going to add 3/3 here. Because 4 and a whole make 5, right? So 4 and a whole make 5. So I'm just rewriting that 5 as 4 and 3/3. Okay, so now my denominators are the same, which is awesome. So I'm going to keep my denominator. And 3 take away 2 is 1. And this 4, and there's nothing here, so 4 take away 0 is 4. And this problem's done for me. I'm all done. So remember to think about with whole numbers, you may have to borrow. So keep that in mind. Now, there is another way to do this. So let me show you what it is. This is our last example with subtraction, but I want to show you just because some other people like to think about it this way, and I'd like to show all the different ways. So I'm going to do this problem again a little bit differently. Some people like to take this 5 and say, Mrs. Darlis, I don't want to borrow 1. I'm going to make this into an improper fraction in terms of 3s, right? So they change this to be 15/3 because 15 divided by 3 is 5. So they want to just take the whole thing and go from there, which you can do. There's nothing wrong with that. You can do it that way if you want. So then you have 15 take away 2. 15 take away 2 is 13, okay? And then, you keep that same denominator. So you're back to where you were over here. If you make it an improper fraction, you're going to end up with an improper fraction. And once again, you're going to have to do a little bit of long division. So you're going to have to put 13 in the house, 3 outside. 3 goes into 13 4 times. 1 left over. So there's that 4 and 1/3. So this is going to reduce down to 4 and 1/3. Same answer we got before, right? So that's another way of doing it. So that's 2 different ways to do a subtraction problem when borrowing's involved. So hopefully this different denominator idea makes a little bit of sense to you more.